This is Geometry, Unit 10, Day number 4. We're on volume of spheres and composite solids. So a sphere is a set of all points in space from a given point, called the center of the sphere. We know that a circle, the definition of a circle is a set of all points, but that's on a given plane. That's on a flat surface, all the points equal distance from its center location. So in this case, we are in space, we're three-dimensional. So when we calculate the volume of a sphere, we've been talking about how many of our shapes are 1/3. Okay, 1/3 base times height is the cone and the pyramid. This one, similar to that, it's not 1/3, but it's 4/3. 4/3 pi r cubed, where r is the radius. So when we come down and we talk about the exact value of the volume, the exact is going to have the pi symbol like it has in many of our other shapes. So we know in this case that the radius is 12. So we're going to take the volume, which is 4/3 pi r cubed, and we're going to plug in the 12 in for the r. So that gives us 4/3 pi 12 times 12 times 12.
1,728.
Nice, 1,728. And when we multiply this together, we can either divide by the 3. Okay, divide by the 3, then multiply by the 4, or vice versa. But we're not going to multiply by the pi because we want the exact value. When you multiply by the pi, we would get a decimal. And then the decimal gets rounded, and it's no longer exact. So that's 2,304 times pi feet cubed. If you had a 12-foot radius, that'd be a pretty big sphere. That'd be pretty big. I think it'd be a little too big for a beach ball. A beach ball has a diameter of 15 inches. Find the volume to the nearest hundredth. Now here they talk about hundredth. So yes, we are going to use a decimal. Yes, we are going to calculate with the pi. So if we know the diameter is 15, then that means the radius is going to be half of 15. Very good, 7.5. So we can go to our volume, which is 4/3 pi r cubed, and we're going to plug in our radius, which is our 7.5 cubed. And when we calculate that 7.5 cubed, we're going to get 421.875. If we divide by 3 and multiply by 4,
That's the nearest thousandth, by the way.
That's okay because we aren't rounding our work. We're going to round our answer. So then we'll get volume equals 562.5 pi. And when we calculate pi in here, because they want to the nearest hundredth, they don't want pi to be left over in the value. So there's our 1,767.15 inches cubed. Remember, these are cubic inches when you're talking volume. When you're talking the complete length times width times height type of concept. Okay. The next one says find the radius. All right, when it says find the radius, we've got to work backwards a little bit. So we're going to start out with our formula, 4/3 pi r cubed. Now, what are we going to do with this 36 pi? Notice it has the pi symbol. Okay, good job for both of you. 36 pi. That is the volume. Find the radius of a sphere with a volume of, that means the volume is 36 times pi. So we use 36 pi. 4/3 pi r cubed. So if we wanted to, we could divide by pi first. You got a few choices of what you could do, but the neat part is that the pi's are going to cross out. And we're left with 36 equals 4/3 r cubed. So you have a few choices of what you can do here. Now, since we're working with a fraction, we're working with 4/3, I wouldn't suggest to divide by a fraction. Right? I would say take your denominator, multiply by 3 to this side, so the denominator will go away, and you multiply by 3 to this side, which will keep your equation balanced. So we get 108. And the 3's cross out because you have a 3 on top and you have a 3 in a denominator. And that leaves us with 4r cubed. So here we're going to divide by 4. And 4 goes into 128 27 times. So that gives r cubed the value of 27. So r times r times r is 27. We've got to take the cubed root of 27. So that we can get r all by itself. When you take the cubed root of something cubed, you get that value inside. So 3 is going to equal the r value. These are 3 centimeters. So if you have a volume of 36 pi, so you know how much you want to be inside the item. You just don't know what that's gonna, the size that that's gonna make this sphere. So you have the volume, and you've got to figure out just how big that item's going to be. Well, apparently it's just going to be 3 centimeters. All right, when we have a composite solid, composite solids are solids that consist of 2 or more solids. So you've got to be looking at the different shapes that are here. We're going to be adding 2 parts together. This would be the volume addition postulate. As we have talked about several other addition postulates throughout the year, this is going to be the volume of a solid.
You don't know how you can find the
Is the sum of the volume of the non-overlapping parts. What's that?
you guys want to know how you can find the cube root on your Texas Instruments calculator?
Nice. Yes, please let us know.
There is a math key And it's the second, I mean, the third from the top on the left. On the main control panel.
Good job. So on your graphing calculator, there is a math key right here. It says math on it. And we hit our math key and several different topics come up. So you can take the cubed root. Right there is number 4. Yeah,
Number 4, if you want to.
you can. That goes right to it. So then you would type in your 27. And that's how we know that the cubed root of 27 is 3. That is one way, if you're not familiar. All right, when we look here at this composite solid, what do you see? On top, there is a pyramid. On bottom, there is a cube. Okay, so we have 2 things that we're adding together. So we've got to keep those 2 things separate. The formula for a pyramid is 1/3 the capital B times H, which is the volume of the base times the height, which is just going to end up being length times width times height. And the cube, we could call that length times width times height. You could also call that SSS for side, 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 since all sides are the same length. That's what makes it a cube.
I just realized something. 6, 6, 6.
Yeah, very exciting. So here we have 1/3 for our pyramid. That is going to be 6 by 6. And the height, now look at what they're pointing to with the height. You've got to be observant to that. They are pointing to the measurement that is straight up. So the height of this pyramid is also 6. And then the cube itself has a length times width times height, which is a base times height, the area of the total base times the height. So those are all your different calculations. So 6 times 6 times 6 is 216. We actually had that calculation twice. When you take 1/3, it's kind of neat if you take your 1, 2, you add your 2 together. So 2 plus 1 plus 6. 2 plus 1 plus 6 adds up to 9. 2 plus 1 plus 6 adds up to 9. Since 9 is divisible by 3, this is a fun trick to know that 216 is divisible by 3. And that'll go into there 72 times. So we get 288 meters cubed when you add those 2 solids together. So this is called a composite solid because we have 2 solids that we're adding together. For this next one, you have to think about what you have. What shape are you working with? Again, you see 4, 4, 4. So you see a cube. And you also have another part. It's the rounded part. So it's kind of like a can of soup, a soup can, but it's only half the soup can. Okay, so it's going to be half of a cylinder. We know that the cylinder is pi r squared times the distance in between the circles. But we only want half of it because only half of it is above our cube. Yep, it's showing up. And then the cube itself, we could say length times width times height, or SSS or S cubed, or even just capital BH, the area of the base times the height. Now, what is our radius? Because when we calculate a cylinder, we need to know what the radius is. We know that this total distance across the bottom is 4, so very good. It's going to be half of that because the center to the edge is not going to be all the way across. It's only going to be half the way across. So the radius is going to be 2. But the height is going to be 4. And we have 4 times 4 times 4. Oh, I put in an H, sorry. What goes in for our H? I think I said it, but I wrote the H. So that was a 4 for the height. 2 was the radius. Good question. Four times 4 is 16, and that 16 times 4 is 64. So we have half of 4 times 4. Got another set of parentheses in here too to close off that one. 4 times 4 is 16, so we have 16 pi plus an additional 64. And when we take half of that 16, that is going to be 8. And from here, these are unlike terms. You cannot say it's 64 plus 8 pi. It has to be separated calculations. If you wanted to do that with your calculator, you could type in the 8. You would not have to hit the times button, but you could. You could say 8 times pi or 8 pi. The calculator can handle that. 8 pi plus 64. And that comes out to 8913. And that's rounded to the nearest hundredth. All right, so if we were going to talk about the exact value, doesn't look like I did exact value on either. This would be exact because there was no pi symbol, right? We just calculated it out, so this is exact. This here would be the exact. That's the exact answer. There's no way to simplify that down any further. We could just call that inches cubed. But if in most cases, we would combine our like terms to get a decimal, just so we're familiar with that, that would be our decimal version of the exact. If you ever have a question which method you should be showing, you can easily show them both, because it's difficult to come up with the decimal version without first coming up with the exact. So here we have this pill capsule. So we have a cylinder in the middle, and we have 2 halves of a sphere on either end. So it's another composite solid. we have a cylinder, and then the two halves of a sphere is going to make a full sphere. So we're going to calculate the cylinder plus one full sphere. The cylinder's formula is the base, which is pi r squared, times the height. We know it's not 1/3 because it's not coming to a point. This is not a cone. It's not 4/3 because the cylinder itself is not a ball. The 4/3 goes with the sphere. And that is 4/3 pi r cubed. So we look here and they tell us that the radius is 2. So if the radius is 2, that makes things somewhat simple for us. So the height is going to be the distance in between the circles. Height of a cylinder is not necessarily ground to up, but it's going to be from circle to circle. The radius of each half sphere, which makes this full sphere, is also a radius of 2, of course. So that's going to be 2 cubed. So this is going to be pi 4 times 7, which is 28. This is going to be 8. So 8 times 4, if you want to do that all together. 2 times 2 times 2. It's not 6. A lot of people make a mistake and call that 6. That is 2 plus 2 plus 2. This is 2 times 2 times 2. That's 8 times 4 is 32 divided by 3 pi. Now that's really as far as we can take that. We could get common denominators. All right, you have to take the 28 and turn it into a denominator of 3, but we'll turn this into a decimal version.
Where did the
32, that was at 2 cubed. 2 cubed is 8. 8 times 4, 8 times the top of the fraction is 32. And the denominator is still 3. So we have 28 pi plus, we have 32 divided by 3, and we are timesing pi. Now, if that confuses you a little bit about, are we dividing by pi because it's divided 3 times pi? If you're not sure about that, you are welcome to put parentheses around the fraction. That way you're certain to do the calculation of the fraction and then times that by pi. But I believe that was going to work out for us anyway. We got 121.47. And these are our centimeters cubed. So you go ahead and think about this next one. What does it mean? A solid consists of a hemisphere, which is half a sphere with a radius of 1 meter on top of a cone with the same radius and a height of 5. So there would be our hemisphere. And there would be our cone. And the cone itself is 5. So go ahead and try to set this up. If you're watching the video, you can pause it, give this a try, then come back and check out the answer. So we're going to have our cone, and we're going to add the half sphere. The cone's formula is 1/3 pi r squared, that's the base, times the height. And we're doing half a sphere, which is 4/3 pi r cubed. So that's our 2 different formulas that we need to be somewhat familiar with. You can look back at your notes, be able to see those. Now we know our radius is 1. So the cone is going to be 1/3 pi 1 squared. And the height is 5. When we come over to the half of a sphere, the radius is still 1. Radius of 1 makes it pretty simple to work with, because 1 times 1 is just 1. So that's 1 times 5. And this is 4/3 pi r cubed. So 1 times 1 times 1 is still 1. Now we can take 1/3. It doesn't go in there evenly, but we can at least write it out as 5/3, because the 3 is going to divide the 5, or 1/3 times 5 is 5 divided by 3 pi. In this case, when you have a fraction timesing a fraction, you multiply the tops together, so we get 4. You multiply the bottoms together, and we get 6. You're doing a good job. That 4/3, when we cut it in half, we got 4/6. That can actually reduce, because you have the 4 and the 6, which is reducible. So you could call that 2/3. The advantage of 2/3 is that this one over here is 5/3. Oh, I see what's going on. So you could say that you have 5/3 pi, and you have 2/3 pi. I just reduced the 4/6. I reduced the 4/6, so I had common denominators. Now, if you notice, it's a fraction times pi and a fraction times pi. This would be like terms. So this could be 7 pi, or 7/3 times pi, or 7 pi divided by 3, however you want to phrase that. That would be your exact answer. But it does say round to the nearest 100th. So we can use our calculator and say 7 divided by 3 times pi, and we get 7.33. And that would be our total volume of the sphere and the cone. All right, last question, number 7. Here we have a swimming pool. Very appropriate after the weather we've had, minus the rain. If you look at this pool, you might consider it being a little bit easier if you break it into 2 shapes. You break it into a rectangular prism and a triangular prism. Now that is something we could calculate for. Otherwise, we had a trapezoid, and we'd have to know our formula for a trapezoid, and that still could have worked then if we were familiar. Here we have a rectangular prism and a triangular prism. So the rectangular prism is base times height. And the triangular prism is half. We'll call that a small base. This is a different height. This is the height between the triangles. So we can call that like H1. It's different than just the H we're doing for the rectangular prism, most likely. And we have a different height for H2. So there's a different H1 and a different H2 for each other.
Add the, make the H capital and add an O, capital O after the 2. Therefore, we have water in our pool.
Nice job. I like that. 164, because that would be 164 times 82. That would be the area of the top surface times 4, which would fill in the pool. That's this first portion. The rectangular prism is now completely filled in. Plus, because it's a triangle, we say half. Our base has to be a perpendicular side. So if you notice that this whole thing here is 10, this portion is going to be 6, and this portion is going to be 4. So the triangle is going to be 6 times, that's this portion here, which is 6, all the way down, which is 64, 164. And this H2 is the distance in between the triangles, which is 6. No, it's not. It's 82. Sorry. Any concerns where that's coming from? I know there is a lot of calculations in there. Keep sliding it. And so we have the base of our rectangular prism. All right, in my visual, I thought about the very top being a base. So the very top is 164 times 82. That's the very top. And we fill that up for the 4 feet. Then we take the triangle, which is on the side, and we figure out half the base times its height, which are perpendicular to each other. And we times it by 82, which is a distance between the triangles. So with our calculator, we come up with 53,792. This comes up to 400. Well, actually 40,000, if using a calculator, 40,344. So we add the two together to get 94,136. These are cubic feet.
Now we need to find a gallon.
We're going to turn this into cubic gallons, or just gallons, because gallons is a three-dimensional concept. So what we have to do, we have to recognize that 1 gallon one cubic foot is actually 7.48 gallons. 0.5 if you want. Yep. Let's think about this for a moment.
And with that, we get 704,184.35 gallons.
Perfect. We have 1 cubic foot equaling 7.4805 gallons. So every cubic foot equals many gallons. So we're going to take our cubic foot and times it by our gallons.
These guys? Wait, these? Look. These look like paper towels.
Okay, so that multiplies out to be our number of gallons. So when you're filling this pool, the pool flows at a rate of 23 gallons per minute. So we're going to take the total amount and divide that by the 23, because that's how many gallons per minute is being flushed through. And that tells us that this is going to take us 30,000 minutes to fill the pool. And we can convert this into hours by taking our 30,000 and dividing that by 60. So I see this as 110, 510, and we could actually take that. What would be our next amount? If that's hours, what could we?
Days.
We could do this into days. And
24.
How many, if these are hours,
Approximately
24. So we're going to divide this by 24, and that's going to tell us how many days it's taken to fill this pool. So obviously we need something a little bit more quicker to fill this pool up. These are days. These here were hours. These here were minutes. So we're just kind of clumping together these different items. All right.
And if you really want to, 3.04 weeks.
You could break that into weeks too, and you know that there's 7 days in a week. So nice job, everybody. That was an interesting calculation. It's kind of more of a real world calculation.